So last thing we're going to do is we're going to look at multiplying and dividing again, except we're going to learn a much easier way to do it. Okay, when we did multiplication and division before, it's not hard, but it's kind of an involved process, especially division. You got to find the conjugate. You got to multiply top and bottom by it. Then you got to FOIL what's in the bottom, FOIL what's in the top. So there's 4 multiplications right there. Anytime you get I squared, you're going to change them to negative ones. Then you're going to combine like terms. There's a lot to do. Well, if we're just willing to write our complex numbers in polar, we can eliminate doing all that. And we can make it so we can do it in our head, basically. Right? So what I just said, polar form of complex numbers is going to give you a quick way to do multiplication and division. So I'm going to start out by writing 2 complex numbers. Okay, we'll call the 2 complex numbers Z1 and Z2. Okay. The first complex number has a radius. We'll call it R1, and it has an angle. We'll call it theta 1. When we do an actual problem, R1 and theta 1 will be numbers. Okay. The second complex number, it also has a radius. But it doesn't have to be the same as the first one. It could be different. So I'm calling it R2, my second radius. And it has an angle. I'm going to call it theta 2. If you want to multiply these 2 together, okay, all you have to do is take the 2 radii that you have, R1 and R2, multiply them together. So whatever those 2 numbers are, just multiply them together. Okay, the next step is you take the 2 angles, theta 1, theta 2, and add them up. And that's it. You multiply the 2 radii together, and you take the 2 angles, and you add them up. And that's the final answer. Okay, the only disadvantage to doing it this way is you have to have your complex numbers in polar to start. If they're not in polar, well, that's what we learned yesterday, how to change it to polar. But honestly, if they were not in polar to start, it might take longer to change them to polar, use this shortcut, than it would be to just FOIL it and do it that way. This is probably only faster if they're already in polar, okay, like in this problem. Okay, so after we go through a couple of these, you should be able to look at that, figure out what to do with the 3 and 5, figure out what to do with the 120, and you can do this in your head. And what you're doing in your head is equivalent to all that foiling and I squareds and everything you had to do when you did it in rectangular. It all goes away with polar. It becomes a lot easier. Okay, so this time, my first complex number is 3 cosine 20, I sine 20. And my second one is 5 cosine 100 plus I sine 100. Let's multiply them together. All right, Jimmy, what do I do with the 3 and the 5? Yep, it says take R1, multiply by R2. What's 3 times 5? 15. Okay, that's half of what we have to do. Last step, figure out our angle. All right, so when we're multiplying, go back up, look at the formula, see what it says. Okay, Christine, when we're going to multiply, what do we do with the 2 angles? What's the formula say to do with them?
Oh, add them?
Add them. Theta 1 plus theta 2. What's theta 1 in this case?
20.
20. Theta 2?
100.
100. Add them up. What do you get?
120.
120. We're done. That's it. That's how you multiply two two complex numbers together, bless you, using polar. Okay, any question on that? Okay, so hopefully you can see how much faster that was. You didn't have I squared, you didn't have foiling, no combining like terms, none of that. Okay, it's a lot faster.
So we don't even have to type that into a calculator, you basically just plug
That,
it.
yep. If you can do 3 times 5 in your head and 20 plus 100, then no, you don't need a calculator. Now, if it was like 3.7 times 5.1, you know that, you might want to use a calculator for that.
So that take on an you don't have to like type that into the calculator?
No, no. If you were to take the cosine of 120 and multiply by 15, and then take the sine of 120 and multiply by 15, you'd be converting it to rectangular. They didn't say to do that here, so you don't have to. In my pre-cal class, we generally take it one step further and do that, but for this kind of problem, we don't need to.
On the test, do we have to?
No, no. Okay, another problem. This time, z is 1/2 cosine 15, I sine 15. And w is 10 cosine negative 30, I sine negative 30. And they want to find z times w. Let's start with our radius. Yeah, go ahead. Yeah. Take R1 times R2, 1/2 times 10, 5. Now we take our two angles. Mariah, when I'm multiplying, what do you do with the two angles?
You add them.
You add them up. What's 15 plus negative 30?
Negative 15.
Yeah, good, negative 15. Okay, that's fine. Okay, technically we could leave the answer like that, but on the test I might get rid of these negatives. So Katie, how can I get rid of the negative with the angle that's with cosine?
Add 360.
Okay, one way to do it is to add 360. Do you remember how we did it a little bit more clever, keeps the angle the same size?
Did you plug it into the calculator? The cosine, negative.
So I used the calculator to show you the pattern, but we don't need a calculator to do it now that we know the pattern, what happens. You help her out? Yeah? Yeah, with cosine, you can forget about the negative. It doesn't make a difference. You just get rid of it. With sine, you can't get rid of it, but you can move it. Yeah? Move it in front. Okay, to me, I think the second answer looks a little bit cleaner. You don't have as many negatives. And it could be written like that on the test. So just understand these are the same thing. And you could also add 360 as well. Okay. So any question on multiplying in polar? All right. Let's look at the same thing again, except now we'll do division. All right, so same two complex numbers. And if you understand how we did the last formula, this one you could probably figure out just by kind of reasoning it through. Last time we multiplied the two radii together. What do you think we're going to do with them this time? We're going to divide them. Okay. We're going to do R1 divided by R2. Now, last time when we multiplied, we added the angles. Now we're dividing. What do you think we'll do with the angles? We're going to subtract them. Yep. So it's very easy in the sense of the operations you need to do. Just divide R1 and R2 and subtract your angles. I think the hard part is it's so similar to the last one, sometimes people mix them up. They start adding when they subtract or multiplying when they should divide, things like that. So just make sure you follow that formula. All right, so example 3, we got two complex numbers. Z is 3 cosine 75 plus I sine 75. And W is 5 cosine 30, I sine 30. Okay, on the test, I'll tell you in the directions what I'd like you to find. In this case, they're asking you to divide. Z divide by W. Okay, be careful, because it could say W divide by Z. That would be a little tricky if they did something like that, especially if they write it in this order, but they want you to divide it in a different order. That'd be almost like a trick question a little bit. But I'll generally try to write the numbers in the order I want you to do the problem. Okay, so first thing, let's figure out what we do with 3 and 5. Chelsea, what am I going to do with 3 and 5? I'm going to divide them, 3/5. Okay, don't even bother writing it as a decimal, just 3/5. And Cassandra, how do we get our angle? What do we do?
You subtract 75 from 30.
Subtract what from what?
75 from 30.
So that would mean to do this. Subtract 75 from 30, or other way around?
No, the other way.
Subtract 30 from 75, yeah. So what would you get?
45.
Yep, 45. Now, if you did it the other way around, you'd get a negative, and then you might get rid of that negative, but it would mess up the answer. So always do it in the order they write it, Z minus W. And that's it. So everything we just did there, that takes the place of finding the conjugate and all the other stuff I said. You don't have to do any of it. Questions on that? Okay, let's try one more with division. Okay, so this time Z is 10 cosine 20, I sine 20. And W is 1/2 cosine 100 plus I sine 100. In this case, you don't really need the extra parentheses around the 100. I usually put them in when there's a negative, just so you understand the negative is with the angle. But I added them in because I already had one there for some reason. So. All right. Charles, what's my radius going to be here?
10 divided by 1.
Yep, 10. And what's 10 divided by 1/2?
20.
20. Okay, now some people say, well, shouldn't it be 5? No, 10 divided by 2 is 5. 10 divided by 1/2, that is 20. Okay, and my angle. Danielle, what's my angle here?
20 minus 100, so -80.
Yep, negative 80. Any question on that angle, negative 80? Okay, last thing we'll do, let's get rid of the negative from the angle, but let's do it without adding 360. So Ryan, what would be my final answer doing what I just asked?
So would you use get rid of the negative for cosine,
Yeah, for the cosine, you can just get rid of the negative. That's fine.
and then just add negative I sine.
And then for the sine, you can't get rid of it, but you can move it in front. Not every problem has a negative, so sometimes you don't even have to deal with that. It's only if you have a negative that you gotta think about it. Okay. Any question on that one? All right, so last thing. All right, so when we did arithmetic, we did add, subtract, multiply, divide. What would that mean to do? How could you rewrite that? Say if somebody doesn't understand what numbers up high mean, you'd say, oh, well, we could rewrite it without this number by writing. Yep.
Double distributed.
What is it?
Double distribution.
Okay, that's how you solve what you're going to rewrite, but what would you actually write?
Oh, parentheses, 3 plus 2i.
Yep.
Close parentheses, 3 plus 2i.
Okay. Just as a really quick review, let's just do it out. This isn't too hard. We get 9. We get 3 times 2i, that's a 6i. Another 3 times 2i, that's another 6i. And we're going to get, yep, 2 times 2 is 4. I times I is I squared. Then we got to change that I squared to negative 1. So 4 times negative 1 is negative 4. And 9 minus 4 gives me 5. Okay, so not too bad. I mean, that didn't take more than 30 seconds or so. Now, if I asked you to do something like this, it's still not too bad, but now you have to write 3 plus 2i, 3 plus 2i, and 3 plus 2i. Yeah?
What was the name of that? You changed it to that.
Oh, we're going to go back to that.
Oh, okay.
This is going to lead into that.
Yeah.
Okay. So this, again, you'd have to do it like this. Okay, the shortcut that people try to do is they say, oh, I'll cube the 3, cube the 2i, and I'm done. No, it doesn't work that way. You've got to write it out like this. And then we'd do the first two. We'd FOIL them out. We already know what we get, 5 plus 12i. That's the first two. And then you'd have to multiply by 3 plus 2i again. All right, so it would take a little bit longer. 3 plus 2i to the 39th, now that's going to take a really long time. To do it this way, your chances of making a mistake pretty high. You're probably going to have to do almost 100-something multiplications, combining like terms. Nothing that's hard, just extremely tedious. Or even something like this. Now it's nearly impossible, okay, to do this way. Well, this theorem allows us to take a number, raise it to any power we want, and make it just as easy as the way we were doing multiplication and division. You could tell me to raise something to the 3rd power or the 3 millionth power, and I could do either one just as fast. Might need a calculator because the numbers will get a little big, but I'm not going to have to do tens or hundreds of multiplications. It's going to be very, very simple. Okay, so the way you pronounce that is Dubois Theorem. And it's basically, you can think of it as a trick to raise a complex number to a power. But the trick only works in polar. Okay, that's the whole key to everything today. You've got to have your number in polar. Okay, so what's the trick say to do? Well, it says to take the radius and raise it to the power. What's the power? You'll be given that in the problem. So you take your radius, raise it to the power, and then look what you do with your angle and the power. You multiply them. Okay, we've had problems where we add 2 angles together, where we subtract 2 angles. This is one where we're going to multiply an angle by a number. And you do it here as well. Okay, so whatever your radius is in the problem, you're going to raise it to the power they ask you to. Whatever the angle is in the problem, you're going to multiply it by the power they ask you to. And that's it. Okay. If I asked you to raise something to the 8th power by hand, you'd have those 8 sets of parentheses, and you'd have to FOIL or double distribute every single one of them. Even somebody that was really good at math, it's going to take them at least a few minutes to do it. This is faster. Okay, so let's start with our radius. I'm going to take my 3, and what do I do with it to find the new radius? Jordan?
Go to the 8th power.
We're going to raise it to the 8th power. Take your radius, raise it to the power. How do I get my new angle? What do we do with the angle we have and the power? Yeah?
Multiply it.
Multiply them. Take your power, which in this case is 8. Take your angle, which in this case is 20 degrees, and multiply them. Okay, and then we'll do that out. And that's it. That's all you really have to do to raise something to the 8th power in polar. 3 to the 8th. Let's see what that is. If something starts to come out in the millions or billions, that's going to be a little big to write. But 3 to the 8th power, it's getting kind of big, but it's not too big we couldn't write it. It's 6,561. If it starts to get much bigger than that, I wouldn't bother. Okay? Even that's kind of big. And what about my angle? Jen, what's my angle going to be?
8 times 20.
Mm-hmm.
So
160. And that's all you have to do to raise that number to the 8th power. No foiling, no combining like terms, no I squareds, nothing. That's the whole trick. Right, so hopefully, if you didn't quite understand why you'd write something in polar, you can kind of see the advantage now, how fast multiplication and division are, and how fast raising to a power is. Okay. Right. Any questions on that? All right. All right, so the homework picks up same page you left off with last night, 333. I'd like you to do 33 to 37 odd, 41 and 42, but don't follow the directions they have in the book. They ask you to do some kind of conversion with it. I'm telling you, just leave whatever you get in polar. Don't worry about changing it. Okay, so we'll go over that before our test tomorrow.